Okay, in this video, I'm going to work through some of the problems out of Chapter 5, Section 3. And this is dealing mostly with how to draw graphs that are polynomials and how to interpret the different pieces. We will get some more theorems in later sections that will let us do a better job of graphing these. But for now, how can we proceed? So the first question is on the left, f of x equals 3x to the fourth minus 27x cubed plus 60x squared. The first thing we need to do is try to factor this as much as we can. So looking at the coefficients 3, negative 27, and 60, I know I can factor out a 3. So the first thing I'm going to do is factor out a common factor of 3. And then the next thing I want to do is I want to take out the variable to the highest degree that's common to all, which is x squared. So I can rewrite my f of x as 3x squared times, leaving behind, x squared minus 9x plus 20. Now, remember that factoring is a form of division. So 3x to the fourth divided by 3x squared gives me x squared. Negative 27x cubed divided by 3x squared gives me negative 9x, and 60x squared divided by 3x squared gives me 20. So for those of you who have trouble doing that in your head, remember that you can always take each term and divide directly by the common factor, and that will tell you exactly what is left behind. So the next one is negative 27x cubed divided by 3x squared, and that leaves behind a negative 9x, which is that one. And then the final one is 60x squared divided by 3x squared. The x squareds cancel, and I get 20, which leaves that behind. Now, we're not done until it is completely and utterly factored. To be completely and utterly factored, I can't have anything higher than degree 2 at most, and even then, only if it won't factor more. And this one will factor more. The x squared minus 9x plus 20 does factor as the product of two binomials. So I need to go ahead and try to factor that. So what I'm going to do is keep going. So I'm going to have my f of x again. The 3x squared is going to stay at the front. Now I'm going to factor the other two. And there are some things out there on D2L in my factoring folder to help you with factoring if you're struggling with that. So I know that x squared splits as x and x. The signs in the middle are both positive because of the plus, or they're both negative. The plus tells me they're the same. The minus tells me they're both negative. So that makes that minus and minus. I need two factors of 20 that add to give me negative 9. It's got to be negative 4 and negative 5. Negative 4 minus 5 will give me negative 9, but negative 4 times negative 5 gives me positive 20. This will give me the x-intercepts that I need. The x-intercepts come from each factor, as we saw in the last video on 5.2, coming from each part. So again, here's my first factor. Here's my second factor, and here's my third factor. Factors are separated by dots for multiplication. The 0 for the first factor is 0. If x is 0, then 3x squared is 0. The second one is 4. If x is 4, then x minus 4 will be 0. And the third one is x is 5. When 5 is 0, then when x is 5, x minus 5 will be 0. Now I'm going to take each of these and put them on the graph. So I'm going to make some tick marks to account for my spacing. And I'm going to put balls where each of these are. The graphs definitely hit at these spots. The next thing I need to look at is how many times did each one occur. So my x-intercepts, if I list them just by their coordinates, were 0, 4, and 5. The 0 occurred twice because of the power of 2. We call that a multiplicity, meaning it's there 2 times, multiple times. The 4 was only there once because the power on the x minus 4 was an unwritten 1. So we say it has multiplicity 1. The 5, the x minus 5 factor was also only there once, so it has multiplicity of 1. When you have even multiplicity, the graph will hit that x-intercept, bounce off, and stay on the same side of the axis. Otherwise, if it's odd, they'll cross over the line. So now I need to look and figure out what my degree is. If I'm looking at this one, what would the degree of the overall thing be? To find the degree, you're going to take the highest degree term in each individual factor and multiply it together. So to find the degree, I need to take the 3x squared times x to the first power times x to the first power. That would give me 3x cubed. That means the leading coefficient is 3 and the degree of the overall polynomial is 3. Because the leading coefficient is positive, but the degree is odd, that means it's generally an uphill graph, meaning it goes to negative infinity as x goes to negative infinity, positive infinity as x goes to positive infinity. And in between, it's either going to wiggle or it's going to get flattish. Ours is going to wiggle. The other piece we might want to go ahead and write down would be the y-intercept. But notice that up here for an x-intercept, I got the origin 0, 0. If the origin is one of your x-intercepts, it is guaranteed to be the only y-intercept. You never have more than one y-intercept because it has to pass the vertical line test. It has to be a function. Now let's draw the graph. I'm going to take the graph and show that it goes down towards negative infinity as x goes to negative infinity. It goes off towards positive infinity. As x goes to positive infinity, the y value goes up forever. In between, I need to cross the x-axis when the multiplicity is odd and bounce off when it's even. I usually put a small lowercase b near the x-intercepts that have even multiplicity. That would be at the origin. So it's going to bounce, come back down, cross. Uh-oh, what's wrong? Let's go back and look at our graph and see if we've messed something up. This isn't working. So let's go back and troubleshoot. I made the error on purpose to see if you could follow along and figure out where the error is. Take a moment and see if you can find it. You're right. The problem is when I multiplied these together, I did have 3 factors, but I had x squared times x times x. This number right here should have been x to the 4th. Let's correct that now so that we can fix the degree, and that will change which way it opens. We'll do the corrections in red. This should be 3x to the 4th. The leading coefficient is still 3, but the degree is now 4. What does that change on the graph? If the degree is even, then it should be up on both ends, left and right, and either get more flat in the middle or wiggle up and down in the middle. The leading coefficient is positive, so that both ends go up. Let's come back to our graph and remove the pieces that I have and try to draw it the correct way. So let's take that off and that off. All right, drawing it in red now. Since it's degree 4, it has to come up from the far left and up on the far right and go off towards positive infinity since the leading coefficient is positive. It should bounce at the origin because it has an even multiplicity, cross at 4 because it's odd multiplicity, and cross at 5 because it's odd multiplicity. Notice that this time the graph worked. That is your clue that you have something wrong. If you can't draw the graph with the bounces in the correct place and the crossovers in the correct place, you've probably made a mistake somewhere. You need to stop, go back, and fix it. Let's look at the next problem. This problem is x to the fourth minus 121x squared. Again, first step is to try to find a common factor. The coefficient on the first term is 1. The coefficient on the second term is negative 121. I won't be able to bring out any coefficient that's common, but I do have x squared that's common to both terms. So I can rewrite my function as x squared times x squared minus 121. Again, factoring one thing out doesn't mean you're done. You need to keep going until every factor cannot be factored anymore. X squared is a monomial term, so it cannot be factored anymore. However, the x squared minus 21 is the difference of two squares, and it does factor again. This becomes x minus 11, x plus 11. That's that difference of two squares pattern, also called the conjugate pattern. This will give me my x-intercepts. To find the degree of the overall thing, let's take the leading coefficient, the top power in each factor, and multiply them together. X squared times x will give us x to the fourth. That means that my leading coefficient is a positive 1, and my degree is 4. That means that it has to go up on both the far left and the far right, and either will wiggle in the middle or get very flat and then go back up. What about the x-intercepts? The x-intercepts come from setting each individual factor equal to 0 and solving. If x squared is 0, then x is 0, which is the origin, 0, 0. This must also be the y-intercept. The origin is both an x and a y-intercept in all cases. The second factor, x minus 11, gives me an x-intercept of 11, 0. And the third factor, x plus 11, gives me a factor of negative 11, 0. Now let's mark these off on the graph. To mark them off, I'm going to put a ball at the origin and a ball at 11, 0 and a ball at negative 11, 0. Now I go back and look at the original factors to find their multiplicities. The 0 solution came from x squared. That means it has multiplicity 2. It's there 2 times, which means it will bounce at that one. X minus 11 was only there once. That means it has multiplicity 1, so it will cross. X plus 11 was there one time, so it will also cross. Now, the graph is going to go up on both ends because the leading coefficient was positive and it's even degree. That means on the far right, it's up towards infinity, and the far left, it's up towards infinity. Now I'm going to bounce at negative 11, go up, come back down, cross through the origin, and cross back through 11. That's basically what it looks like. Let's take a look at the next example. The next example, I can factor out a common factor of 2 before I get started factoring anymore. If you can take out a greatest common factor, you should always do it at step 1 because that will make it much simpler. This gives me f of x equals 2 times x to the fourth plus 8x squared minus 9. This is what we call an equation that is quadratic in form, meaning it's not degree 2, it's not quadratic, but it behaves like one. If you look at the middle term, 8x squared, you know that you will have to split the x to the fourth up as x squared times x squared. That will give you back the x to the fourth. The question is, how do we split up the 9 so that we can get 8 in the middle? The last sign is a minus, telling us that the outside and inside will subtract. So I need two factors of 9 that subtract to give me 8. It has to be 9 and 1. The question is, are they both positive, both negative, or one of each? Since I'm subtracting, they'll always be different. So I need one positive and one negative. To get a positive 8, I should have a plus 9 and a minus 1. X squared plus 9 is prime. It will not factor anymore. But x squared minus 1 will factor into the difference of two squares pattern. This gives me, finally, 2 times x squared plus 9 times x minus 1 times x plus 1. If I go back to the original problem, I can see that the degree of the original problem is 4 and the leading coefficient is 2. So the degree on the original is 4, and that's coming from the power on the highest degree term, and the leading coefficient is 2, and that's coming from the coefficient on that term. Since the degree is even and the leading coefficient's positive, it will again be up on both ends. Even do the same, up on both ends if the leading coefficient's positive, down on both ends if the leading coefficient is negative. Now let's find our x-intercepts. We're going to take each factor and set it to 0 to solve. 2 does not equal 0. It's not wrong, it just doesn't give us an x-intercept. X squared plus 9 equal to 0 would give us x squared equals negative 9, which means that x is plus or minus the square root of a negative 9, or x is plus or minus 3i. Imaginary numbers do not show up on this number line because the number line is only real numbers. They are solutions to the problem, but they're not real solutions to the problem, meaning not real numbers, not that they don't exist. That means our x-intercepts have to be coming from x minus 1 equals 0 or x plus 1 equals 0. X minus 1 gives me 1 for the solution, which is the ordered pair 1, 0. X plus 1 equals 0 gives me negative 1 for the solution, and the ordered pair is negative 1, 0. Each of those occurred only one time in the original problem as a factor, which means they both have multiplicity of 1. Now, when I go back to the original problem, I can put onto the graph where these x-intercepts are. I have 1 at 1, and I have 1 at negative 1. When I put them on there, it's supposed to go up in both directions. That means that my graph has to be looking something like this. The question now is, does it bounce or does it cross? And the answer is, it probably is going to cross. Now, why do we know it crosses? We know it has to cross because the multiplicity of each of the x-intercepts was odd. That means it has to come down and do something like this. It is possible that it comes down and does something like this below the axis, but I can't get that level of detail from the information that I'm given. To get that level of information, I would need to have a graphing calculator or know something about calculus. That's beyond the level of this course. Let's take a look at the next problem. This is more similar to what I will give you on the next exam. On this problem, we're given the polynomial in factored form. First, let's figure out what the overall degree of the problem would be. To find the overall degree of the problem, I'm going to take the highest degree term in each individual factor and with its power and multiply them together. My two factors are x plus 1, which is being squared, and x plus 4, which is being cubed. The highest degree term in each factor is x. So I'm going to take x raised to the second power times x raised to the third power, which gives me x to the fifth. This time my degree is 5, which is odd. Because it's odd, I'm going to have one arm up and one arm down. The leading coefficient is whatever coefficient is attached after multiplying those highest degree terms together. So my leading coefficient is 1. Because it's positive, it should be generally uphill, which means that my graph will come up from the left, do some wiggling or flat in the middle, and then go up towards infinity. Now let's find our x and y intercepts. The x-intercepts can be found by taking each factor and setting it equal to 0. So x plus 1 equals 0 gives me the solution x equal -1 and the ordered pair -1, 0. How many times did x plus 1 appear in the original factored equation? I had it there 2 times. That means it has multiplicity 2, and since that is even, that means it will bounce. So on the graph at -1, I'm going to put a lowercase b next to it to know it bounces there. My other factor was x plus 4. If I set that equal to 0 and solve, I get the solution x equal -4. That's the ordered pair -4, 0. Again, this one appears multiple times in the original function. This one appears 3 times, which means its multiplicity is 3. Because the multiplicity is odd, it is going to cross at that particular spot. In fact, it is going to cross and it's going to be almost horizontal at that point. So now I'm going to put this one up here on the graph. So -4 would be -2, -3, -4, there's -5. So I have something here and it should cross, but it should cross at a more or less almost like a horizontal little section. If I look back to the left, I can see my degree of 5 means it should be coming up from the bottom, crossing over, bouncing off, and then going up again. What's my y-intercept? To find the y-intercept, you need to let the x-coordinate be 0 in the original. This means I have 1 squared times 4 to the third power. Now 4 to the third power is 64. And since that's 64, that gives me the y-intercept of 0, 64. Now that would be very difficult to fit onto the graph that I have right here. But I can, if I want to, extend it a little bit up, and I could also label a spot and just say, you're 64. So again, it's got to come up from here and it's got to cross through 64, but it has to bounce at -1. So it's going to come up. Now let me show you a little bit better how it's going to approach. It's going to come up, it's going to flatten as it gets here, then it's going to come back across, come back down, bounce, and then go up. So we have this kind of weird shape going on here. But again, there are no sharp corners and no pointy parts. It should be smooth and connected. But keep in mind, when you're hand drawing, it's not going to be perfect, and I'm not looking for perfect. Close will be close enough. Let's take a look at this next problem out of section 5.3. In this problem, you're given information about the graph, but you're not given the equation or the graph. They want you to come up with the equation for the graph. We're told that the degree of the equation is 4, and that we have roots of multiplicity 1 at x equal 4 and x equal 5. Let's put that much together. That means I have f of x equal, If the solution is 4, then I can work backwards to the factor by subtracting the 4 from each side. That gives me the factor x minus 4. Since the multiplicity is 1, the power on that factor is 1. For the second solution, or x-intercept at x equal 5, I can back that up by subtracting 5 on both sides to get the factor x minus 5 equals 0. Again, the solution 5 is linked to the factor x minus 5. In section 5.5, this will be important as we work on long division and synthetic division. Since the multiplicity on that factor is also 1, its power is also 1. We do not have to write the 1 power, but it's not wrong if you do. The next one says that we have a root of multiplicity 2 at x equal negative 4. This time I have x equals negative 4. To solve for the factor related to that solution, I need to add 4 to both sides of the equation. When I add 4, I get x plus 4 equals 0. So my factor here is x plus 4. And my multiplicity would have to be 2. Let's see if I can write this a little bit better and get my stylus working again. What's missing now is the piece of information about the y-intercept. The way I've set it up, I've just accounted for the x-intercepts, but not the y-intercept. That can be affected by the numbers inside each factor raised to their powers and any leading coefficient. So I'm going to put an a at the beginning so that I can account for that. To find the value of a, I simply need to replace all the variable x's with 0 and set it equal to y equal negative 4. That's the y-intercept. So I'm going to write negative 4 equals f of 0, which is a times negative 4 to the first times negative 5 to the first times 4 squared. This will let me solve for a. Multiplying out the right-hand side, negative 4 times negative 5 is 20. 4 squared is 16. 20 times 16 should be 320. This gives me 320a. Again, that's 20 times 16. When I want to solve for a, all I have to do now is divide both sides by 320, and I get a equals negative 4 over 320, or by reducing, I can get negative 1 over 80. My final function to meet all the conditions is negative 1 over 80 times x minus 4 times x minus 5 times x plus 4 quantity squared. This will meet all the conditions that were set up in the original problem. I believe we have one more problem to take a look at, maybe two more. This next one is a word problem. It's very similar to the one I worked at the end of section 5.2. In fact, it's basically the same. You have a rectangle of length 15 units and a width of 5 units. Let's draw that rectangle. So I have a rectangle, and it is 5 wide, and it is 15 long. I'm going to cut squares out of each corner that are x by x. If I cut them out, it means that each little corner is x on each side, and I'm going to cut them out. Every corner is x by x. So that when you're done, what you will have is you will basically have a small section with the corner cut out. Did I do that right? I think I did. Okay, coming across like that. Then you're going to take and you're going to fold it right here on each of these edges, and you're going to fold the boxes up. So this will fold up, this folds up, and then you will tape the two sides together to create an open-topped box. We want to express the volume of the box as a polynomial function in terms of x. If I started with a length of 15, notice that I cut off an x from each end. So this must be now 15 minus x from the left end minus another x wide from the right end. The width has to be 5 minus x from the top and minus another x from the bottom. In other words, my new length is going to be 15 minus 2x, and my width is now 5 minus 2x. This is the length and the width of the open top box. To get the volume, I need to multiply those by the height. If I fold up the little flaps, the sticking out rectangular sections, then the height of each little section will be the x that I cut out. So this would be times x. This would represent the volume of the box. It looks a little funny with the x at the back, so if you want, you can swing it around and put it at the front. It is not wrong to have it at the back, it just looks funny. That's it. That's the entire volume of the box expressed as a polynomial. Let's take a look at one more word problem. In this word problem, we have a right circular cone with a radius of 4x plus 3 and a height of 2 units less. Express the volume of the cone as a polynomial function. They give us the formula for the polynomial of the cone. They gave it to us as 13 pi r squared h for a radius of h and a height of h. I'm not sure what the 1/3 is coming from. I'm wondering if this is a typo, because it should not be 13. It should be divided by 1 divided by 3. So let me add in some notation. This should be 1 divided by 3 in parentheses times pi r squared h. That's the volume of a cone. Or if you want to write it, another way of writing it is 1/3 pi r squared h, where they're all multiplied together. Okay, now let's take a look and draw a picture. My right circular cone is basically like an ice cream cone, and I'm going to draw mine kind of upside down. The base is a circle. The circle has a radius from the center to the edge. The radius of the circle is 4x plus 3. The height of the cone is coming from the tip at the top down to the center of the circle at the base. The center of the circle at the base is where the height of the cone meets. So when I write the height, it says it's 2 units less than the radius. 2 units less means the radius minus 2, which would be written as 4x plus 3 minus 2, or 4x plus 1. Now let's write the volume of the cone. To write the volume of the cone, I'm going to write the volume depending upon x is given by 1/3 from the formula, pi from the formula. The radius is 4x plus 3, and it's squared, times the height, which is 4x plus 1. That is an expression for the volume of the cone in terms of x. That's the last example I have for section 5.3, and I hope this has helped to explain the material.